Hello everyone. Okay, it's about time to do this clock measurement, and I just made a few changes to various things, but first I'd like to show you something that's missing. This experiment was initially based on this article in the in Yahoo News from the Associated Press, and if you search for this article now, you'll find it's gone. This is what happens when we click on the link. Article not found or expired. Okay, so maybe they get rid of those articles, but there are some others here which I guess would be the same story. Power grid change may disrupt clocks. Okay, so why am I making this video today? Well, because the time has changed again. Okay, so while that loads, let's pull up this clock. Update it again. I just done it actually about 5 minutes ago. We're just on 6 o'clock, which is the time we do our measurements. Oh, there we go. Something's gone awry. The page you requested could not be found. I wouldn't be surprised if every reference or every article on the story has been erased. Anyway, it's in response to that bizarre news story that actually started this experiment in the first place. So, let's see, we've just updated the clocks, and I'll just show you what I've done over here. I've normalized the times, so because some of these, well, one of these watches, one of these timepieces is actually 2.5 seconds slower days, so I've added an adjustment into it to compensate for that, so we can get these all on the chart going horizontally. And of course, this cube clock, which is this one here, was so unreliable that I actually pulled, or appeared to be so unreliable, I pulled it out of the experiment. However, after reading some stuff about quartz crystals and things to do with quartz and how it was used by the ancients, and I decided, well, maybe I shouldn't just pull out the unreliable quartz clock, because there might be something to it. And as it says here, let me see, it talks about if we if a bell were shaped by grinding a crystal of quartz, it would ring for minutes after being tapped. Almost no energy is lost in the material. Now here's how quartz crystal oscillators work. The electronics of a watch initially amplifies noise at the crystal frequency. This builds or regenerates into oscillation. It starts the crystal ringing. The output of the watch crystal oscillator is then converted into pulses suitable for digital circuits. These divide the crystal frequencies down and then translate them into proper format for display. This is how these crystal clocks work, or these crystal timing oscillators work. Okay, so what I decided it might be of interest is perhaps it's not that this particular clock, the cube, which I call the cube clock, is not so much it's unreliable, it's just more sensitive. Unfortunately, I cut it from the experiment at this point here. I decided, when it made that drop, I thought, I can't use this in the experiment, so I dropped it. However, on, I think it was the beginning of the month, or August 9 by the looks of it, I brought it back in. And the reason I brought it back in is because I was finding out more information about quartz crystals, and I started to suspect it might be the crystals themselves which are changing their speed of oscillation. So I wanted to test this. And this is the first day we've actually had a significant dip. We've been basically very consistent, apart from that last dip which happened which recovered from that on August 9, August 10. We came back up again. And okay, the cube clock's been climbing and climbing, and I actually do an adjustment on this. I actually take 8.4 seconds off that clock every day to keep it within the graph, within the range of the zero line on this chart. And I did that, it actually was at the 40-day mark when I brought it back into the experiment. So taking the amount of time it was out at that time and dividing by 40, I came up with subtract 8.4 seconds from the time. Okay, so but it seemed to be racing off anyway, so I wasn't sure when this was actually going to turn around, and today it did. Okay, so today we've had a turnaround, and what we have here is these ones, these are two other clocks which are very consistent. They both lost, relative to yesterday, 1.75 seconds, and this one, it appears to have lost, let me see, it should have lost, normally it would lose 2.5 seconds, but in actual fact today, yesterday to today, it lost 5 seconds. So both of them dropped more than they should have. They shouldn't have dropped at all. But what's interesting is this unreliable quartz clock actually dropped even more. So it should have actually gained 8.5 seconds or 8.4 seconds between yesterday and today. It was at 450 seconds ahead yesterday, and it's 454 today. So it's actually 4.5 seconds slower today than it should have been, or 4.4 seconds slower today than it should have been. Okay, so these are the times. This is, let's pull up that clock again. And you should see that this is the case on this. See, it's actually now behind, and if we're looking at this yesterday, it's almost exactly one. Oops, I can't see it. I'm looking at it and you can't see it. So it's almost exactly 1 second behind, and yesterday it was about 1.75 seconds ahead. This one's actually almost perfectly in sync as well, but it's behind the time that it should have been. Okay, and this one, this is a bit of a crude way of measuring it because it doesn't have seconds. So I basically just wait for the cube clock to flick over, and then as soon as it flicks over, I read the time up here on the display. So I'm really only within the second on that, so I don't do fractions of a second, it's just not practical. So this one turns out to be the best one of all in our experiment, because it actually does appear to be the most unstable, and by being unstable it's actually showing that it's not the internet server time, or it could be still, but it seems to be the clocks themselves. It seems to be the quartz oscillator is changing speeds. Okay, I've got to find out exactly what that correlates to, but I'm sure it correlates to something. I think we're going to get this flick over in a few seconds. Okay, or did I miss it? I must have missed it while I was talking. Okay, so thank you for watching, and I'll have an update probably tomorrow, a much shorter one than today, just to see how far down this actually goes, because obviously in this point here we must have had a drop and recovered again, but I don't know what actually really happened. So we'll wait until tomorrow, or maybe the next day, see how long this drop continues for. Okay, thank you for watching.